The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. I'm Sharon Dooley, and I'm going to be the moderator for this session. We have a very exciting presentation today about SQL Server dump analysis, something I have never known how to deal with. I just ignore them. And so I'm going to learn something, and I hope you all are going to learn a great deal, too. I'd like to thank our sponsor, Dell Software. It's their contribution that makes it possible for us to have the raffle for each of the sessions, and we are very grateful for their support. If you're not familiar with SQL Saturdays, they're happening all over the place. These are just a few of the ones that are coming up in the near term. They're always on a Saturday. They're a single day, and they're great free training events. You may be asked to pay $10 for lunch, but that's the only thing you'll have to pay. And they're well worth checking out. Find one near you and try it out. We're the past DBA virtual chapter. There are a whole lot of other virtual chapters, and if you're interested in getting on their mailing list, simply add them to your profile at Pass when you log in. You'll hear from them about what they're doing, just like you hear from me about what we're doing. Some of the meetings are listed here, and the DBA chapter meets second Wednesday and fourth Wednesday of every month. So check the others out. The Business Analytics Conference is coming up. I didn't realize this slide was largely invisible, but you can register for the conference. It's going to be in April in Santa Clara, California. It should be fairly decent weather in Santa Clara in April. If you're not busy at the beginning of March and want to make a trip to Denmark, SQL Rally is going to be held at the Tivoli Hotel there, and there's a discount code if you want to save 5% on registration. Please consider volunteering for PASS. All these virtual chapters are entirely run by volunteers, and there are other things that are done by PASS that are also run by volunteers. Each month, there's a volunteer selected as the outstanding volunteer, and then annually there is a Passion Award that's given to a volunteer who has made a significant contribution to PASS and the global data professional community. This says the same thing as the other. I don't know why I didn't take it out. And this says the same thing as one of the others too, but this is a picture of the awards. And please stay involved. Connect with us on LinkedIn, Facebook, Twitter. Visit our website to find out all the events that are happening. And now I'd like to introduce Prashant Kumar, who is doing our presentation today. He has almost a decade of experience working with SQL Server database administration. He worked for the PSS team at Microsoft and currently works at Pythian as a principal consultant. He's an MCTS and IT professional as well as an Oracle professional, and he has a blog at SQLactions.com and is on Twitter as @PRKuma. And now I'm going to turn the meeting over to Prashant.
All right, I got it, Sharon. Thank you. You able to see this?
Yep.
All right. How do I minimize this window? No. So, Sharon, how do I minimize this window? Do you know? Okay. Okay. All right. Hello, everyone. Today we are going to talk about SQL Server dump analysis. My name is Prashant Kumar. I'm working at Pythian as a principal consultant. And as Sharon introduced, prior to Pythian, I was working at Microsoft, where I learned dump analysis. Here's my contact info. You can contact me through my blog or email shown over the slide, or Twitter would also be a good way to reach me. Let's look at the agenda for today. Okay, so today we are going to have a quick introduction about the dump files. Then we'll talk about some basic Windows concepts which are required for analyzing the dumps. Then we will look at some of the tools available for creating or analyzing dump files. Next, we will look at how to install the debugger, what are the symbols and why they are needed under the fourth section, WinDbg setup and configuration. Then the fifth one, we'll have a quick demo on, fifth and sixth one together. We'll have a quick demo on how to load the symbols and the dump files into the debugger. And next we will talk about different types of dumps in SQL Server and how to analyze them with some cool demos. The seventh is going to be in pretty much detail. In the eighth, we'll have the demos, and ninth, the resources, the references. And at the end, we'll have a Q&A session. All right. So let's start with the introduction to the dump file. So what is a dump file? A simple definition would be it is an image of the memory space for a process at a given point of time, so that we can dig into it later as what was going around the time when some problem occurred. As we see here in the slide, a memory dump is of two types: user mode dump and the kernel dump. Okay, user mode dump has the content of memory written into a file for an application, particularly for an application running on Windows. The extension of such user mode dump is usually .mdmp or .dmp. While a kernel dump is that of the operating system, that is Windows itself, and probably some applications running onto it. One thing I'd like to tell you is the dump analysis requires good understanding of Windows memory management as we deal with the memory addresses, the virtual address space, and so forth. And also it is an advantage to have some level of understanding of the programming language in which the application you are debugging is written into. For example, SQL Server is written into C++. You know, in the dump, you will see all those kind of functions, structures, variables, which you can correlate to C++ kind of coding style. So if you know C++, you can actually correlate those stuff. And you know, once we look at the dumps, you will see those functions and the structures and variables in a few minutes from now. So that was about the dump file. Now a few words about the art of debugging. So just a kind of heads up or advice here that analyzing a dump alone is often not sufficient to establish a root cause. While it can give us a good pointer, a good start that what potentially could be the problem, but maybe we need to look at some other things as well. We actually need to have a very strategic approach, which includes but not limited to reviewing various logs. For example, in SQL Server, you might want to review error log, the SQL Server agent log, the event viewer application and system logs, cluster logs if that is a cluster and there was a cluster failure or something. You may have to use some tools like Portmon, Profiler, Netmon. Also, sometimes when things are not obvious, you need to establish and test the hypothesis. Okay. For example, let's say I'm looking into a corruption dump, the database corruption dump, and I drill down a corruption issue to the fact that select a star from sys indexes also results in an error. So that's a hypothesis which I have established by looking at the dump. Now I test it by checking which indexes might be corrupt, or in fact that might be a statistics which might be corrupt. So yeah, I'd like to test that hypothesis, and I'll figure out, I'll drill down to the database indexes and stats level. So yeah, but still, by looking at the dump, we may have some pointers, a place to start with for further debugging. Now, so as I said, we are going to talk about some Windows concepts, especially the memory concepts, which may be needed for our dump analysis. So here's a slide which talks about 32-bit address space layout, a very basic one, but I'd like to quickly go through it. I think we all probably know the virtual memory management and virtual address space techniques in Windows. Just to recap, the total virtual address space for 32-bit versions is 4 GB, 4 gigabytes, right? Every process can see and use 2 GB of virtual address space. The rest 2 GB is reserved for the system. In this slide, at the bottom here, you see, at this place, I have translated 32 bits from hex to binary. You see these hex values here and the binary values, which is equal to 32 bits. All right. So this I have done because this is something which is relevant to our dump analysis. When we will have a demo, you'll be able to relate it. So as you see here, this 32 bits is equal to 4 bytes or a D word, all right, and 64 bits is equal to 8 bytes or a Q word. So we use this command dd on a 32-bit dump. dd stands for dump D word, and similarly dq, that is dump a Q word on a 64-bit to dump the data. Okay, we'll actually be using this command, so you'll be able to relate it during the demos. Let's go to the next slide. This one, 32-bit versus 64-bit memory, virtual memory. Yeah, we just discussed about it, like, the total amount of virtual address space is basically 4 GB for 32-bit versions and practically unlimited for 64-bit versions. And also the amount of virtual address space for 64-bit processors is 8 terabytes and 64-bit version, not applicable for 32-bit versions. Just to keep in mind, and probably this is one of the main reasons we keep telling our customers to move to 64-bit if they are running 2005, 2008 or so. Okay, now we are going to look at this slide which talks about programs, processes, and threads. This is the last slide on Windows concepts. I'll mainly talk about process and threads. SQL Server, to be precise, the executable, which is SQL Server.exe, is a process. It spawns several threads controlled by SQL OS. All right. And then we know threads are the basic entities which execute instructions. Okay, so we will literally see the threads inside a dump during our demos. So I'm going to talk a bit more about threads. What are they? What do they contain? When we'll see a thread inside a dump. So threads are composed of changing set of registers, a private storage area, one of which is used for user mode, and the other private storage area is used in the kernel mode. And the thread also consists of a thread ID. If we know the thread ID, we can directly jump to the corresponding stack inside the dump. All right. So we will see this during demos. But yeah, I want to talk about threads because normally we look at the threads and we look at the stack contained by the thread inside a dump to know what's going on. So yeah, that was about Windows concepts. The next section is about tools of the trade. So let's see here. Okay, so we have, I have listed some tools here. For example, the debugging tools for Windows, which is a part of Windows SDK. And once you install debugging tools for Windows, it has like 3-4 debuggers within the package itself: WinDbg, CDB, KD, AD+. Then there is a debugger tool. There's a native debugger of Visual Studio. There's a proc dump, and there are many other debuggers available as well. These are some of the tools, which are either used to analyze the dumps or to create the dumps. There are many other debuggers available as well. In fact, you can create your own debugger because Microsoft provides functionality in dbghelp.dll for developers, which will have an API to create their own debuggers. During our demos, we'll be using WinDbg to debug SQL Server dumps. WinDbg, as you see here, that's a part of Windows SDK, as I said. It can also be installed standalone, and it is a GUI-based debugger. WinDbg is the most popular debugger, at least for SQL Server dumps, or at least what I have seen so far, and is really a very powerful tool. So we'll be using WinDbg to load and analyze SQL Server dumps. So let's talk about WinDbg and how to install it and all. So WinDbg setup and configuration. Okay. So choose the right installer. Okay, so yeah, basically, we need to install WinDbg, right? So we can install WinDbg on any client machine or the server itself, but I strongly recommend not to install it on the server. Rather install it on your laptop or your local desktop or somewhere, a client machine where you can copy the dump files and then look into the dumps. So yeah, and then to get the installer, this WinDbg installer, you can search internet for these search terms: debugging tools for Windows or WinDbg. There are separate packages for Windows 8 and Windows 7. I have mentioned the link here. And one important thing here is WinDbg can also be installed via Xcopy. Means once you have installed it on your on your office laptop, let's say, now you just copy that folder where you have installed it and put it on a different laptop. You don't need to re-download the package again. So that's as simple as that. Let's have a quick look at the installer screen of WinDbg. I have put in two screenshots here. This one. So this is about the destination folder where we want to install the WinDbg. I generally recommend to install it in a directory without any spaces, so maybe D drive debuggers or D drive WinDbg, something like that. Okay, and if you only want to install debugging tools for Windows, then during the installation options, you might want to uncheck all others but debugging tools for Windows. So just keep this in mind while installing WinDbg, and always remember the path where you have installed it, because we'll have to go inside the path and then launch WinDbg from there. All right, now this is important one, symbols. So symbols. Symbols are files. They contain the data that map the executable code back and blah blah. But let me try to make you understand symbols in a different way. When a program is written, let's say SQL Server, it ships a lot of binaries and executables, including SQL Server.exe, which is the main executable. All right, but SQL Server.exe has only as much of code as necessary to execute the instructions a user can pass, right? But when it comes to debugging a dump caused by SQL Server executable, we may need to know a lot more information, like the name and addresses of the global variables, their structure, the function names, the address and their entry points, etc. So this all information which is required for debugging is kept aside in a separate file, which are called symbol files. All right. So whenever we load a dump, we need to load the symbols so that they can align and they can provide us the meaningful information, and then we can start debugging. So symbols are very crucial, very important, and to load the symbols correctly before debugging is a important item. Also, just for your information, in the early versions of Windows NT, the symbol files used to have the extension .dbg. Windows 2000 and later versions have the extension .pdb. Okay, so symbol files will have an extension .pdb. We'll see that. Also, just to mention, symbol files do have the names and the addresses of global variables. They may also have the function names and addresses of the entry points. As I said, there might be FPO data, the names and location of the local variables, the source file paths and line numbers as well. If you are dealing with private symbol in case of SQL Server, or it may have type information for variables, structures, and a lot more information. So yeah, symbols are very crucial. We will have a demo where we will load the symbols. We'll make sure it is loaded correctly and then load the dump. And another one is about how do symbols help in debugging. So just to give you a visual idea here, if you look at the slide, on the left side, you see, without symbols, a call stack would look like this, So this is the model name, SQL Server plus some address. That's it. If I load the dump with symbols and look at the call stack, it will look like this. So it has the SQL Server, the model name, and then the function name, and then some offset. So that makes more sense to me than this one. So that's how it makes sense to load the symbols correctly and start debugging. one more slide on symbols, I guess. Yeah. The public symbol versus private symbol. Okay. So yeah, there are two types of symbols. I'm specifically talking about SQL Server here, at least. So one is called private symbols. The other one is called public symbol. Microsoft makes public symbols freely available to everyone, while private symbols can only be accessed within Microsoft. Okay. So public symbols have the global variable names, function names, entry points, like we discussed. Private symbols, they include all the information contained in the public symbol plus a bit more, actually a lot more. Like the private symbols will have the local variable name, the source file paths and the line numbers, the type declaration for the variables, structures, and so on. So and then private symbols are necessary for debugging with the program source files available, or at least they are best used with the source files available. While public symbols are usually sufficient for analyzing problems in the absence of source codes. So with private symbols you can do much more, but then they have limited access. So we'll be dealing with public symbols, but still we will try to gain as much information as we can from the public symbols and try to make some sense out of it. So this was about public versus private symbols. Here's a quick one on setting the symbol path. All right, so as you see, there are like 4 ways, to set the symbol path. You can use the environment variable called entry symbol path, or you can use the -y command line option, or you can open the debugger, and there's a GUI option here, a symbol file path under the file menu. From there also you can set it. The second screenshot is for symbol path, the GUI option, and you can also use the command .sympath inside a debugger to set the symbol path. Okay, so there are various ways to do this. Within a couple of minutes we are going to have a demo on this, so you'll have more clarity. Let's figure out what is the symbol path, like from where do I download the symbols. So there's a Microsoft public SQL server. Here's the address you see, https://do.microsoft.com. So this one is the address for the public symbol server from Microsoft. Okay. But here's the thing, you cannot browse through this site. Rather, the debugger would download the symbols on a need basis. Depending upon what terms you have loaded, what kind of modules are there in the term, the debugger would download the symbols itself, provided that you have given the correct symbol server name. And how the debugger does it by using a DLL called sim.srv.dll, which is inside WinDbg. So it uses that DLL to download the symbols. Here you see I have mentioned a downstream store. So what is this downstream store? Right. This downstream store is just a local cache, so that whatever symbols will be downloaded will be put into this local cache, which is just a folder on your hard drive. So let's say D drive / public symbols. That's our downstream store, and our symbols will be placed inside that cache. Okay. This is done because the next time you load a dump, it would first check the local cache. If it finds the symbol there, it won't go to the public symbol server and try to re-download it. Rather, it will reuse the same local cache, the symbols from the same local cache. And here is the command .simfix. This is another way. So actually, you don't need to remember the symbol server, this HTTP blah blah. If you inside a debugger, if you simply type .simfix, it will actually set the symbol path to this Microsoft symbol server, http://mstl.microsoft.com. We'll see this. Okay, so if you just remember this command .simfix, that's enough. Actually, let's have a quick demo at this point. So I have installed my WinDbg here under D drive debuggers. But for this particular demo, I'm going to use the WinDbg from a different installer folder, that is D drive demo symbols, because I already have the symbols loaded in the D drive debuggers folder. So okay, so we are inside D drive demo symbols, and just look at the contents. As you see here, this is actually WinDbg installer package, but then we have AD plus inside it. We have CDB, the other debugger we talked about. Then we have KD. So these also are the tools, the debuggers. We are going to make use of WinDbg. You see the WinDbg.exe. That's our WinDbg debugger. We will launch it. So whenever you have to launch it, go to D drive, your installer, your WinDbg installer folder, and launch WinDbg. Or otherwise, I have actually put this on the desktop, so I can launch it from here. But that's actually D drive debugger. So yeah, just the ways to launch it. So we launched the WinDbg. Then we will go to File and open crash dump. And I'll go to my demos folder, the load dump. So I'm going to load this dump into WinDbg. So if I provide the path here, it will show me this. So I can either launch it this way, or I can simply drag and drop it as well. Either of them works. So I just drag and drop it. Okay. Now before we load the symbols, let's have a quick look at the information debugger shows us soon after loading the dump. For example, here you'll see the dump file name and comment, program fault handler. So kind of access violation or something. And actually it is. The another comment says exception blah blah, exception access violation. So this is an exception, this is an access violation dump. Just by looking at the comment, we know this is an AV dump. In case if it is a non-yielding scheduler or deadlocked scheduler or something, the comment will tell us this is a deadlocked scheduler dump. So here we get to know, okay, this is an AV dump, access violation dump. Here it will display you the server OS, so it was Windows Server 2003, the SQL Server actually where the dump was generated, the debug session time when the dump was generated, the system uptime, and various other information. All right. Now, let's check the symbol path first. If I just type this command .sympath, it says symbol search path is empty. Right. So right now we have not set a symbol path. It shows empty. If I set the symbol path, so if I put this command .sympath and then the my downstream store, so D drive demo symbol sim. This is my local cache, and this is the Microsoft symbol server name. All right. So if I put this, debugger will know that it has to download the symbols and put it in sim folder here. Okay. And this is anyway the default location for putting the symbols, if you don't specify any other location. Right now you see the symbol folder is empty. I go here, I set this symbol path. Now I check the sim path again. It says symbol search path is blah blah. Earlier it was empty. Okay, so our symbol path is set correctly. All right. I will turn on the noisy prompt. Bang sim -noisy. So it says noisy mode, symbol prompts on. This is used to verify, if there's a problem in loading the symbols or what. So it actually displays some verbose information when the symbols are being loaded. So it can, it can be helpful in troubleshooting if there is a problem with loading symbols, or it can, in fact, tell you also the progress of the download, like how much percent the download has completed for the symbols. So I turn this on, and I try to load the symbols using this command .reload/f SQL Server.exe. Okay, if I simply give the command .reload/f, it is going to download the symbols for all the modules inside this dump. That will take a bit of time. So just for the demo purpose, I'm going to download the symbols only for SQL Server.exe. So I have to give the module name, and it will start downloading symbols only for SQL Server.exe. All right. This might take a couple of minutes, so we will revisit. Yeah, so we'll get back to this window. In the meantime, let's continue with our slides. So here's a demo on open a dump and load symbols. Okay, so we are actually doing this. We'll get back to our WinDbg window. Let's actually quickly check the progress. Okay, here actually you see, if you're able to, so here it displays the information. It is loading symbols for SQL Server.exe, 17% complete so far. Right. So maybe it's gonna take 4 or 5 minutes or so. We will verify once the symbols are loaded. So we are actually here. Once the symbols are loaded, I'll show you what is lmvm command, and how to list all the modules which are there inside a dump. We're doing this. So while our symbols are being loaded, let's look at some quick terminologies we frequently use in the world of dumps. So thread call stack. I spoke about threads when we were talking about the Windows concept. Now, more in terms of SQL Server, the thread in a SQL Server dump corresponds to the worker thread. Okay, the worker thread. So actually, if you go to the sys processes table inside master database, there is a KPID column. That is, that is the thread ID. That is the worker thread ID. Or actually, we have a DMVs also, like sysdmos threads. That also displays the worker thread ID. So SQL is written in C++, and the default thread stack size for a standard C++ program is 1 MB, but SQL Server thread stack size varies depending upon the platform, the architecture of SQL Server. We can use the K command to see the call stack. So I'm talking about the thread call stack here. So the command key can be used to look at the thread stack. There are many variations of K command. It is there in the appendix, which I'll make available along with the slides. But yeah, the most important thing is that whenever we look at a thread call stack, we should read it from bottom to top. That's the stack, so it has to be read from bottom to top to know the sequence of events in which the functions were being called. This actually is here in the next slide, walking through the stack. So always read it from the bottom to top, and in a stack, the return address should always be equal to the previous stack entry symbolic name. So we see this return address here. This should be equal to the symbolic name, that is latch base release internal. Okay, that's just an important concept for the call stack. Let's look at the next slide, basic debugger commands. Okay, these are some of the basic debugger commands we use, but this list is not exhaustive. There's an appendix, in which I have mentioned a few more commands which we frequently use, and those are some basic ones. We we will be using during analyzing a dump. You can refer to the appendix for a complete list of, not complete, but kind of exhaustive list of such commands. Let's go back to our WinDbg session and see what's going on here. Okay, so here we see it says dbg help SQL Server public symbols. It has sort of loaded a symbol, D-drive demo symbols, sim SQL Server.pd, blah blah blah. Okay, let's verify. I go to the demo symbols. This folder was empty earlier. Now I see a folder called SQL Server.pdb, and there's another folder with some GUID or something. Inside this, I see SQL Server.pdb. So this is the symbol file, .pdb. So for SQL Server module, it will always be placed inside SQL Server.pdb. For example, if you load another dump now and provide the same local cache store, it will create another folder here under SQL Server.pdb and put the symbols into that. And symbols are different for every version, every build. For example, for SQL 2008 SP1, there will be a different symbol. For CU1, for CU2, there will be a different symbol. So you'll always have to make sure that you load the symbols and then start debugging. Okay, we talked about thread call stacks. So let's see here. This was an access violation dump. So in access violation dump, we go to the context of the thread which raised the exception using .ecxr command. Okay, and if we pass a k command, or let's say k100, by default, if you pass the k command, it will display you, I think, around 20 lines of information. This is called, this what you see here, this is called the thread call stack. Okay, and this has to be read from bottom to top. All right, so this is a thread call stack. If you want to look at the state of the registers, you can pass R command. Okay, so there are 16 registers we see here. So R command will tell you 16 registers, and it will give you the state information about those registers. Let's go back to our presentation. Okay, so we were talking about basic debug commands. And there's one more thing here I'd like to tell you. So apart from the appendix, which I'm going to provide with a list of some more commands, there's a great inbuilt help documentation of WinDbg, which you can refer to for a complete list of commands and many other things. If you just type .hh, or if you just type F1 inside WinDbg, it will open up a help file which you can refer to for the list of commands or anything, any other information related to WinDbg. Okay, so that was all about the debugger commands and quick demo on loading the dump, making sure the symbols are correctly loaded. And I said I'll show you LMVM commands. So here's a command called LM that stands for list modules. If you hit this command LM, it will display you the modules which are loaded, which are there inside the dump. For example, you see here, so here, these many modules are there inside the dumps, and it will display you the information about the symbols for whatever modules we have. So for example, SQL Server, we see the symbols are loaded for SQL Server. For the rest of the modules, it says deferred because we have not downloaded the symbols for them yet. Okay. If you pass LMVM and then specify a module name, LMVM SQL Server, it will display information about SQL Server file. So for example, this is a favorite command. Whenever I load a dump, I will first look at the module information about SQL Server to know the build and all. So if I give LMVM SQL Server, I get to know, okay, this is 10.0.4000, so that's SQL 2008 SP2, I guess. So I know the build version of SQL Server, right? So that lmvm is a very important command again. All right, let's get back to our presentation. Now the interesting one, SQL Server dump files. Okay. So under SQL Server dump files, this section we're going to talk about, SQL Server, when does SQL Server generates a dump file, the location of the dump files, and a bit more. Let's navigate to the next slide for this information. Okay, so this slide talks about the kind of dump files SQL Server generates, or rather, I would say, when does SQL Server generate a dump file? These are some of the scenarios when SQL Server would generate a dump file. When there is a non-yielding scheduler, when there is a non-yielding resource monitor or IOCP listener, when there is a deadlocked scheduler, in case of access violation and database corruption as well, and for latch timers also you can have dumps in certain cases. And for .NET Framework as well, you'll see some runtime exceptions and the dump files. These are some of the scenarios when SQL Server would throw a mini dump. Here's a KB article which you can refer to for the list of event IDs and messages. All right. I'll take advantage, and in this slide I'll talk a bit about non-yielding scheduler or resource monitor. So because most often we see the dumps are either for non-yielding or deadlocked schedulers or access violations. So we are going to focus on this. So for non-yielding, let's first understand what we mean by non-yielding. We know schedulers, a logical CPU used by SQL Server worker threads. SQL OS allows a single worker to own the scheduler at a given point of time. There is a scheduler monitor. Okay, so that comes SQL 2005 onwards. Prior to that, there was a different mechanism, but I won't talk about SQL 2000. So 2005 onwards, there is a scheduler monitor which runs every 5 seconds and checks for any worker thread which has not yielded to another worker thread in the last 10 seconds. It will keep track of such worker thread, which has not yielded in last 10 seconds. And when it finds that particular worker thread has not yielded in more than 60 seconds, the scheduler monitor detects and declares it as a non-yielding condition. Because you cannot monopolize the scheduler. You have to yield in a reasonable amount of time. If you don't, we have to keep track of it. We have to, say that there is a problem probably. So basically, what I just explained is called a non-yielding condition, and depending upon what kind of condition it was, let's say if it happened for a scheduler, we call it a non-yielding scheduler. If it is happening for IO completion code, we call it a non-yielding IOCP listener. If it happened for a resource monitor, we call it non-yielding resource monitor. And this information about non-yielding is also recorded in ring buffers. Just to let you know, usually, non-yielding is caused by SQL Server bugs or some system level issues. Either a kind of bug or a non-issue, or maybe some system level issues. If it is stuck on a network call or something, maybe we have to figure out. So if we know that where it was stuck, why it was non-yielding, we can start our diagnosis. Another thing to note is sometimes the dump generation may be delayed. Okay, for example, if there is a resource condition that may cause a delay in calling SQL dumper.exe, which ultimately writes into the dump file. So in those cases, if you look around the message, if you look at error log when your dump was about to be generated or something, you might see messages like timeout occurred while waiting for external dump. So most likely that was a delayed dump. And this I'm telling you because in case of non-yielding dumps, if you look at the current thread stack for the non-yielding thread, you may not have the right information if that is a delayed dump. So to deal with this, for non-yielding dumps, we have a global structure which is called G_copied stack info. I'll show you this. Which actually in which we actually copy the non-yielding information. So we better go to this structure and try to dump the information about the non-yielding thread. We'll have a demo about it. And okay, we will talk about access violation after 2 slides. Quickly, one line about deadlocked schedulers. So I spoke about non-yielding schedulers. When a particular worker thread is not yielding on a scheduler, it is called non-yielding scheduler. Imagine a situation when all the schedulers, let's say we have 16 schedulers or 80 schedulers, all the schedulers are having the same non-yielding condition. That condition is called deadlocked scheduler. Okay, there are some other conditions to happen in a deadlocked scheduler as well. For example, more than 50% of the worker thread should be blocked or should be waiting for a critical resource type for deadlocked scheduler to occur. But in general, when all the schedulers are in a non-yielding state, we call it a deadlocked scheduler. And please remember, this is completely different from deadlock, what we know in SQL Server. It is a deadlocked scheduler, so it is a deadlock for the schedulers, but no relation with the deadlock we know about SQL Server. Okay, and deadlocked schedulers, there are 2 common causes for deadlocked schedulers. The long-running queries, that is log blocking or some kind of head blocker, or the other common cause is excessive parallelism. That may also lead to deadlocked scheduler. Okay, now about dump files location. So the default location is log folder, and whenever a dump is generated, there are a set of 3 files are generated. I'll show you here. So this is not okay. So whenever a dump is generated, typically it will give you 3 files. One is .txt, the .mdmp, and .log. .txt is called symptom dump. Okay, so that will have some information about the memory status on the server. By memory status, I don't mean DBCC memory status, rather the available physical memory and memory load and so forth, and the exception information and so forth. The .log file would have a snippet from error log exactly a moment prior when the dump was generated. So in case if you don't have error log file, you can still refer to the .log file. And .mdmp is the memory dump itself. And you can also change the default location, which is log folder. You can change this location. If you go to configuration tools, SQL Server error usage and reporting, you'll see the dump directory there. You can specify a different directory if you don't want your log folder to be flooded. Or there is a registry location as well mentioned in the slide here. You can directly modify the registry location to change the dump files location, but I don't advise that. I'd rather do it from SQL Server configuration tools. Okay, we are kind of running short of time, so I'll quickly go through these slides. I want to actually show you some demos. Okay, so we talked about many dumps, but yeah, non-yielding, deadlocked schedulers, and all those. But we have certain other kinds of dump. We have crash dumps, we have hang dumps in SQL Server. And sorry, I missed this slide. I was wondering, yeah. So actually, we have a mini dump, and then we have a filter dump and full user mode dump. But that is not much use, not of much use for us, because filter dump and full user mode dump are best analyzed using a private symbol. So I'm not going to talk much about that. In addition to that, we have crash dumps and hang dumps. Hang dumps especially, they're kind of useful. Let's say our SQL Server agent job is hung and we don't have any clue in the logs or anywhere. Maybe we can take a manual dump using AD+. AD+ is very useful to take such kind of hang dumps. and we can analyze that. So they're much more. Okay, and I said, yeah, we'll talk about access violation. So basically, exception and assertion. Whenever SQL Server hits an exception or assertion, it will raise a dump, and you will see exception access violation in the comments inside the dump. So we actually know about exception and assertion. The important thing is the way SQL Server deals with exception and assertion is common. It will always generate a mini dump in either case. In case of assertion, you will likely see a function called util assert fail or something in the call stack. So that's call stack for an assertion. Okay. SQL dumper.exe. I briefly mentioned about SQL dumper.exe in the previous slides. So this exe actually ships along with SQL Server and is in the shared folder. This is the exe which is called internally by SQL Engine to write into the dump file. Okay, and there's a KB article. You can actually control the parameters. You can tweak them in the cluster to generate the dump according to your needs. Okay. So maybe you'd like to refer to the KB article mentioned here at the end of this slide. And there are ways to control the dumps as well. You can manually take dumps, so SQL Server will generate dumps automatically only upon certain conditions. But let's say we are hitting some strange scenario which we are not able to debug otherwise with the available logs, error logs or so, and we don't have any clue what's going on. Or let's say I fired a simple query, but it is not returning any records and it is there lying forever. We can take a manual dump using DBCC stack dump in that case, and then we can look at the dump to see where our query was hung. So basically, what was the last function executed. That's how we find it out that okay, probably it could not progress after it, and then we try to figure out that okay, if there are any known issues with this function or something, and we troubleshoot. So there are ways to take manual dumps as well. DBCC stack dump trigger. That's also a command to generate dumps for a specific error. I have the commands and their syntax in the appendix, which I'll be uploading along with the slides after the meeting. And yeah, obviously you'd like to be alert when a dump is generated. So various ways, but yeah, the simple ones are like you may have some process to scan the error log for dump generation messages, which is something like this, using dbg help.dll or stack dump being sent to blah blah. So you'd like to scan these messages, and there can be custom tasks to monitor dump directory for the recent dump files. Okay, and this is pretty much it. We will have the demos. Let's see how much time we have left. Okay, very few. I'll quickly try to go through the demos as much as we can. So the first demo I'll have is, I'm going to close this. I'm going to open a WinDbg and show you the demo on this dump. Okay, so I opened this dump 1. I have already downloaded the symbols, so I'm not going to specify the symbol server path, rather my local cache. Right. So I have specified the symbol path here. Then I reload the symbols. It's going to reload the symbols for me. Oh yeah, let's look at the top of the dump here. So it says comment non-yielding scheduler. So I know this is a non-yielding scheduler dump. Fine. So I have loaded the symbols. Now I'll first check the version of SQL Server by lmvm SQL Server command. So this is SQL 2005 SP4, I believe. 9.0.5000. All right. Now, this is my habit. I quickly look at the number of threads. So if you pass on tilde start, it will display all the threads. Okay, so we have 325 threads. They start with 0. So we have 325 threads inside the dump. Fair enough. Let me quickly show you something here, the error log snippet. So in the error log snippet, we see this was a non-yielding scheduler, and process blah, worker blah appears to be non-yielding. So it gives us a thread ID here. I can take this thread ID. This is probably the thread ID for the non-yielding. So I'll take this thread ID and go to the context of this thread, and then I'll look at the call stack using K command, or maybe K100. Okay, but I mentioned about the delayed dumps. So when I was talking about non-yielding schedulers, I did say that, if in case if it is a delayed dump, this information may not be accurate. How do we verify that? I had talked about it, that we have a global structure in which we copy the non-yielding information. That global structure is called G_copied stack info. Okay. So we'll go to the context of the thread which has this copied stack info, and this is at a particular offset. For 64-bit dumps, it is 20. For 32-bit dumps, it is C, hexadecimal C. So we'll go to the context of this, and that is actually valid until, I guess, SQL 2012. In 2014, the offset might have changed. Please don't try it on SQL 2014. So we are in the context of this global thread, global structure, which likely has a non-yielding stack, and then we look at the stack. Okay, this we know for sure is our non-yielding thread, and this is the stack for the non-yielding thread. We read it from bottom to top. All right. If I try to make some sense, and this comes by experience also, you can quickly figure out which is kind of an interesting function here. So if I look here, I see C token access result, security context token and something. That makes me suspicious. It is talking about user store token perm. Okay, so I go to the server, I check DBCC memory status, or I query the token and perm user store cache. I see it is around 625 MB size. Then I search net for user store token perm large size. Let's say, so if you go to user store token perm large size, if you search here, you'll find blogs, and then you'll see some known issues around this. And in SQL 2008, there were some some configuration parameters added as well to control the cache size. So exactly that was our issue. The issue was that, okay, if it goes beyond 100 MB, that is of a concern. We had it 600 MB. Once we controlled it, issue went away. So this is how we find out the issue from the term, that why it was non-yielding, and then we take the corrective measures. Right. I'll try to show one more demo around this on access violation. Maybe I'll close this, open the debugger, demo number 2. Okay. First, let me load the symbols, because that's going to take time, and before I load the symbols, I should give the symbol file path. So here's the symbol file path, and then I'll load the symbols. And while the symbols are being loaded, let me go to the top of the dump and show you. Okay, 1 second. All right, we go to the top of the stack. We see program fault handler exception access violation. So this is an access violation dump. We know this, and we had seen this during our first demo. So this is an AV dump, access violation. And in case of access violation, you will also note debugger will tell you that this dump file has an exception of interest stored in it. The stored exception information can be accessed via .ecxr. So in case of AV, you should always type .ecxr. Okay. Before we type that, let's have a look at the SQL Server version. LMVM SQL Server. This is SQL 2008 SP2 again outright. So we go to .ecxr, the exception context of the thread which raised an exception, and we look at the stack. Okay. If I look at the stack here, what sounds interesting to me is this guy, SQL Server backup file description initialize DE key, and then again, oh sorry, and then again I see some related information regarding encryption. You know, it is trying to load a certificate or decrypt format. So some backup operation was probably going on, probably on an encrypted database. That's what I figured out from this stack. Okay, so I go to my search engine and I type SQL Server, let's say backup. It was encrypted, so TDE access violation. You know, I'll use this search terms. I see a hit. There's a KB article on this. That was exactly our issue. So basically, that was a bug. You know, and the workaround was to use a checkpoint before issuing a backup, manual checkpoint before backup, or there was a CU available as well. We used the workaround, and that did the trick for us. So fine. So this was the access violation done. I think we can go over next 5 minutes more. Let me show you one more, at least, demo on Deadlock the scheduler. This will be our last demo. So this will be on Deadlock the scheduler. So I loaded the dump. I'll provide the symbol path here. All right, and this is a very interesting one. So yeah, we will stop here, but yeah, this is very interesting one. So this is for Deadlock the scheduler. We have given the symbol path. I will load the symbols now. .reload F. Okay. So here we look at the comment. It says Deadlock schedulers. Fine. We have loaded the symbols. Now we are going to check the SQL Server version. LMVM, sorry, there is a typo. LMVM SQL Server. So this is 10.50.1600. Okay, so I believe this is SQL 2008 R2 RTM version, no service pack. Okay. Deadlocked scheduler. So I first take a look at the number of threads we have in the dump. So tilde star will tell me that 743 threads in total, because it starts with 0. All right, so 743 threads are there. I will issue another command, tilde star key. It will do pretty much the same thing as tilde star, but it will also display the call stack information along with all the threads inside the dump. This I'm doing because, you know, the next few commands would need me to scan through all the threads, or, you know, would need me to scan through all the call stacks for all the threads. So I'm doing this in advance to save time. So tilde star key is just going to, you know, display call stack information for all the threads inside the dump, for all the 743 threads to be precise. Okay. Now before we fire our next command, let's see this. As I said, usually the long-running queries, you know, that is lock blocking or some sort of head blockers, or excessive parallelism are the common causes for deadlocked schedulers. So we mainly focus on two things in case of a deadlocked scheduler. At least, you know, during the initial investigation, we mainly focus on these two things. Number one, we will try to find out the threads, you know, that are waiting due to parallelism, or we will try to find the threads that are waiting for locks, okay, or both. And there's a way to do that, okay. So if you issue this command, bang find stack, bang find stack is a command to search through all the call stacks inside a dump. So I'll use this command, and I'll pass the function name SQL Server bang subproc entry point. Okay, this subproc entry point tells me that, okay, no, if it finds any stack with having subproc entry point in it, it tells me that, okay, that was a child thread that was waiting for parallelism or something. That was a child thread for sure. So I search for this. There's another function, fn producer thread, that also you can use for that. I won't display it there because I know it had a blocking problem. So to know, so there was no problem due to parallelism here. Let's see if there was a problem with blockings or excessive locks. So I say find stack and SQL Server lock owner sleep. Okay, and I'll give 0 here so that it only displays the thread numbers. So I give this command, find stack SQL Server bang lock owner sleep. Let's see. Okay, it is giving me quite a few threads. I know this is in total. These are 597 threads, which are having lock owner sleep on their call stack. And if they have lock owner sleep on their call stack, or there's actually another function like LCK lock internal, any of them. So if they have lock owner sleep on their call stack, that means they are waiting for the lock, or they are blocked or something. Okay. Now we had 743 threads in total, and 597 were kind of waiting or blocked. So we know 743 minus 597, that is 146 threads, where those threads which were not waiting on locks or which were not blocked. So there were 146 threads which were not blocked. Also, remember, I said that more than 50% of the worker thread should be waiting, for a critical resource for deadlocked scheduler to happen. So 743 by 2, so 597 is definitely more than 50% of the worker threads. Anyways, so we have 146 threads which are not waiting on the locks. Now this becomes tricky. I had to manually walk through the call stack of all those 146 threads. And what I found interesting was there was only one thread which was executing some T-SQL query, but it was not blocked. Rest all of them were actually, none of them were actually executing any T-SQL or anything. So there was only one thread which was executing. So I know that this thread, was executing a T-SQL, was not blocked. So probably this was a head blocker, more than likely. I know the thread ID, that was 173. So what I do then, I go to the context of that thread and see what it was doing. It was not executing any T-SQL. Okay, sorry, I think I said it was executing a T-SQL. It was not executing. Rest all of them were executing a T-SQL but not blocked. This was not. So I think, okay, probably this was kind of head blocker or something. And in this case, I mean, we cannot figure out what query was this. But if we know that there is a pattern for this deadlocked scheduler dump to happen, then we start our troubleshooting just like a regular blocker, blocking troubleshooting. We set up the blocker script and try to capture the queries or the head blocker information from the time window when deadlocked schedulers are likely to occur, and then we troubleshoot it. But at least we had a pointer that, okay, it was due to heavy blocking, and we have to set up the blocker script or traces to troubleshoot. So, yeah, deadlocked scheduler occurred due to a blocking in this case, and this is pretty much it about our demos. Let me see if anything left here. I had one more demo about resource monitor, but we are running short of time, so I'll leave that. Okay, these are some of the resources you can refer to. There are some books or MSDN article and some blogs, my favorite ones, which you can refer to, and you can learn some more debugging tips and tricks from there. And that's pretty much it about our session. I can probably take a question or two if you have.
Thank you, Prashant.
Yep. Thank you, Sharon.
One of the questions is, at the very beginning, you had a slide with DD and DQ, and what do they stand for?
Okay, DD stands for dump data, and DQ for dump keyword. So that's again dump data, but DD is used in 32-bit dumps, DQ in 64-bit dumps to dump the data structure.
Okay. When you download the SQL Server symbols, you need to specify the version to match the SQL Server version that the dump comes from.
No. So the debugger knows that what is the version of SQL Server, what is the build of SQL Server once you load the dump. Debugger will automatically download the appropriate symbol, and it will display the information. So you don't need to specify anything except the symbol path and the reload command to load the symbols.
Okay, but now I have a question for Sean.
Yeah, sure.
It was better if you downloaded them and had a downstream version. So at that point, do I need to know what the version of SQL Server is?
Okay, are you saying you want to download them to your downstream store in advance without specifying a dump file? Yeah, that's a good question. So yeah, there's a executable called simcheck.exe. You can use the simcheck.exe to download them in advance without loading a dump file. But maybe you'll have to give the SQL Server executable name, or you'll have to pass the SQL Server exe for that.
Okay. How does this troubleshooting and analysis change in the case of SQL Server 2012 and later?
Okay, that's again a good question. So SQL 2012 onwards, there has been a good amount of change in terms of debugging. Prior to SQL 2012, we had just one module, SQL server.exe, and inside the dump also we see only one module for SQL Server stacks, SQL Server bang, some function name. SQL 2012 onwards, these modules have been segregated. They are like, majorly three modules, SQL DK, SQL min, and there's one more which I don't remember now. In which, we have different type of information for linguistic information, or if there is a SQL lang module and all. So you can't just specify .reload/f SQL Server.exe. Okay, you'll have to simply put .reload/f to download all the symbols inside the dump for SQL 2012 onwards. Okay, because there is not only one module but many modules involved. For SQL 2012, the non-yielding scheduler still has the information in the same global structure and at the same offset. So what I showed, the demo I showed for non-yielding schedulers is still valid for SQL 2012. It may not be valid for SQL 2014. I'm not sure. I have not tested it. But yeah, these are the major differences, I would say. Besides, everything remains the same,
Jason has asked, would you be willing to present a series of webinars based on this topic for a deep dive?
Oh yeah, I would be, if time permits. In fact, I am thinking about it. So yeah, thank you so much for asking this. Let's see, maybe in next month or so. I'll think about it.
I can host a series of webinars at a different time from our regular meetings.
Oh yeah, sure. That sounds like a good idea. And yeah, this presentation was overall about dump analysis. But yeah, in the series we can pick up one kind of dump and we can talk about it in deep. Sounds like a good idea. We'll talk about it, Sharon. Yeah.
Okay, great. Jim wants to know, how did you know it was a security cache issue just from that list of processes? Was there something to indicate it was in distress?
Yeah, so there were some function calls like C token access result or security cache token. So I was anyway familiar with those function names, because I have actually analyzed several terms, and in Microsoft also we had a private symbol, so we kind of remember some of the function names anyway. But even by looking at these function names, I could tell that okay, it has something to do with. That was again a guesswork, like I explained initially, that you have to establish some hypothesis and test it. So that was some sort of guesswork also, but I was kind of confident that okay, it is related to user store token form, because it is talking about C token access result and security cache and so forth in the function names. So that's how I came to know.
Okay. That's a question for me. How do we identify? How can we identify if any dump is due to the memory problem? So which function we can use?
Could you please repeat your question, Sharon?
Okay. Let me see if I can make it. I think what Shukabir is asking is, how can we identify if there is a dump due to the memory problem?
Oh, due to the memory problem. Okay. Actually, if there's a memory problem, usually SQL Server will give you another, some other indications, like if the memory is being trimmed and paged out, you will see those messages in error log, like a significant part of SQL Server memory has been paged out, something, or maybe you'll see there's insufficient memory to run this query, kind of error message, error 701 something. So actually, no, in case of memory issues, more than likely you'll have other symptoms in the error log itself than a dump. But yeah, still, if you have a dump file, it will show you some. It will show you some functions which will indicate there is probably a memory pressure. I can get back to you on the function names through which you can identify inside a dump. Okay, maybe maybe after this meeting. Does that answer the question? Sharon, are you able to hear me?
Sorry, my doorbell rang.
Oh, okay. Oh, okay.
Okay, I think we've done everything. Oh, here's one more question. If one doesn't know much about C++, can you advise on which topics to focus on to better understand dumps?
So, if you are actually using private symbols, it is very much necessary to have a basic understanding of C++, because SQL is written into it. But since we are dealing with public symbols, even if you don't know much about C++, nothing to worry about, because we anyway have limited information using public symbols. So maybe it comes by experience and by practice, and that you will be able to figure out and you'll be able to make sense out of a dump, even though you don't know C++. Because if you know there's a structure name, this is the structure name, you can dump it. Or if you know if you look at the function name, you'll be able to tell, okay, probably this is what it is doing. So you don't necessarily need to know C++ if you're using public symbols. But just for the sake of completeness, I mentioned that it is an advantage to know the programming language in which the program is written, which you are debugging. So don't worry about it, I would say.
Okay, thank you very much, Prashant. Clearly, your talk generated a lot of interest, and I have one final thing to do, and that is to announce our raffle winner. The raffle winner is Sandeep Chowdhury, sanadt@gmail.com. And past headquarters will be in touch with you about the prize. Thank you all for coming, and we'll see you in a couple of weeks. And, just keep watching for things. Those of you who have asked about the recording and everything Prashant sends me will be on the DBA